Welcome to the notes for lesson 4.5. We're going to be proving triangles are congruent using two new methods. We have angle side angle and angle angle side. A side between two given angles is called an included side. So side AB is the included side between angle B and angle A. So we're going to use that term down here in the angle side angle congruence postulate. So here's what the angle side angle congruence postulate says. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then we can say that these two triangles are congruent using the angle side angle side angle postulate. So let's see, we have how many things that we're looking for? Same as always, there's always three things that we have to show. In this case, we need to show two sets of congruent angles with the included side in between. So let's see, our blue angles over here, angle A and angle D, and then we're going to need angle C and angle F. That's our second congruent angles. And then we have to have the included side in between. So between A and C, I have side AC, and between D and F, I have side DF. And if those are given as congruent, then I have all three things that I need in order to write a proof. So now we can list our congruent triangles. Triangle ABC is congruent to triangle DEF. And as always, be sure that these are written in the proper order. Okay, let's look at the next one, which is angle angle side. It says, if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So in looking at the examples given in triangle ABC, I have the two angles, but it's not the included side that I'm given, it's the side next to the one tick mark angle. So looking over here, here are my two angles. The side included is not given, it's the side that's on the other side of the one tick mark angle. And since they go in the proper order, angle angle side, then we are able to say that these triangles are congruent. So let's see, as always, we need three things listed in a proof. I need angle C is congruent to angle F, and then I need angle B is congruent to angle D, and I need a side not included. So side AB is congruent to side DE. So since we have angle angle side in the proper order, we can list our triangles are congruent. So triangle ABC is congruent to triangle EDF. And that's the last of our 5 ways of proving triangles congruent that we're going to learn in chapter 4. Flip to the back of the page, and we're going to answer the question, are the triangles congruent, and if so, why? There's 5 methods we know, right? Let's list those 5 methods right now. Okay, there they are. Those are not in the order in which we learned them, but that's okay. And here we go. Let's look at our first problem. We have a side, an angle, and in the same order over here, we have the angle, and the side. And since the side is next to the double tick mark and the side is next to the double tick mark, that means we have angle, angle, side. So yes, we can prove these triangles are congruent using angle, side. Okay, next one. I have an included side between two angles, so that's angle side angle, which is, yes, we can prove this by angle side angle. All right, let's look at the third one. Ooh, we have no congruent sides given to us. All we've been given are some sets of parallel lines. And if you remember from last class, parallel lines give us congruent angles. So in this case right here, based on these two parallel lines, I can go from parallel line to transversal to find those two angles congruent. And then if I'm looking at this other pair of parallel lines, I can go from parallel line to transversal, and now I have 2 more triangles congruent. So let's see, if I have 2 angles, I either need to have angle side or perhaps angle side angle. If I have 2 angles, those are the only options that have 2 angles in them right here. So I either need to have a side that's on the end of one or the side that's in the middle. So let's see where we have congruent sides. They didn't give us any, so we have to use this reflexive side right here as a congruent side so that we can make this triangle congruent to this triangle. So let's look, is that an included side or is that a side that is not included? Look carefully, we have blue, green, red, that side is included, so we're going to be using angle, side, angle. Bottom one, let's look at it together. You notice how this picture looks very similar to this picture? Let's see what has been given. Oh, look, here we got the same congruencies, but this one did not give us these right angles like this one did. So over here, they gave us another given that said DB, that line there, is congruent to AC. Now it gets a little confusing because if I'm trying to prove triangle ADB is congruent to triangle BCA, when the triangles overlap like that, sometimes it can be a little bit challenging, and it helps if you just draw them separately. So let me make some space here. Okay, so now that I have some space, I'm going to sketch these two triangles. So when I look at these two triangles, it's a lot easier to see that so far I have two sides. So let's think about the ways that we could use two sides. Maybe we can find a third side. Maybe we can find an angle in between. And since no information has been given to me that could help me find an angle, I'm going to try to look for a third side. Now here, if you look, it would be really nice if I had side AB congruent to side AB. And actually, if you look back at the sketch, side AB is congruent to side AB because that's reflexive to itself. It's a little bit harder to see that it's reflexive to itself when you've split it up, unless you look and notice the letters AB to AB. That gives us the reflexive side that we need. So we can say, yes, these triangles are congruent using side, side, side. Okay, second column. Pause the video, try them, and then let's check. Now, just because it has a right angle, doesn't that mean that I should be using hypotenuse leg, right? Because it has a right angle, a lot of people assume that it's going to be hypotenuse leg. But did we have the hypotenuse given to us as congruence? If not, we're not going to be able to use that angle as a right angle. Instead, we're simply going to be able to say that these angles are congruent to each other and just have them be the included angle. All right, hopefully you're starting to get the catch of that. And here comes my favorite part. We get to prove triangles congruent using angle, angle, side, and angle, side, angle. Now, from what I've seen, you guys are getting really good at writing proofs. And it sounds like you're having a lot more fun doing it, which is very exciting for me because I love proofs. So here we go. I want you to do what you always do, which is check your given, mark your diagram, look at what you're trying to prove, and after you make your plan, write your givens and get started. So go pause the video and then come back when you're ready. Okay, so hopefully your givens look like my givens, and maybe you even have a few more steps listed. I just switched my givens around. I don't know why I really did that. I didn't write them in the same order. You may have written the parallel lines first. I really like to keep like the parallel lines and any statements that I can get from that together, but that's just how I do it. You don't have to write it that way. So maybe you had the parallel lines first. I like to list those congruent angles first because once I list them, they're done. There's nothing else I need from them. My whole goal from every given is to either get congruent sides or congruent angles, and the ones that gave me congruent angles are done. But now I'm looking at these parallel lines, and I need those parallel lines to either give me congruent sides or congruent angles. And hopefully by now you've seen this enough times that you know that parallel lines are going to give you congruent angles. But we have to go through and figure out which angles they're going to give us. And remember, if you always draw the little angle tick marks from the parallel line to the transversal, from the parallel line to the transversal, then you're never going to choose the wrong angles. From parallel line to transversal, parallel line to transversal, and now I know that these are the two angles that I'm going to use because these are alternate interior angles. Okay, so I took the angle and I wrote him down. I took the parallel lines, I wrote them down, and I got some congruent angles out of them, and I've kind of like used them up. I've run out of givens, I've used everybody up, but do I have enough things stated? Well, over here I have a pair of angles and another pair of angles, but in order for me to use what I'm doing up here, I'm going to need a side now because I'm either going to have angle, angle, side, or I'm going to have angle, side, angle. So let's see what the plan is. I'm trying to prove triangle ABC is congruent to triangle DCB. I do see this reflexive side. So I can use that side to say angle, angle, side, angle, angle, side. Now I know that I can prove my triangle's congruent. Let's write it in. Go. So before I can write angle, angle, side over here, I have to make sure I have all of these marked over here. Then I can write angle, angle, side, and I'm not going to think about it. I'm just going to take this down here and dump it in, and I'm finished. Next proof, here we go. Now the cool thing about writing your own proof is that you may think of a different way to do a proof than somebody sitting next to you. So there's 3 different ways that somebody might come up with to do this particular proof. That kind of makes it challenging for your teacher when they're grading it, but it's fun because you get to do it the way that you see it in your head. So as we do for every proof, we're going to start by looking at what's given, whether those givens are going to give us congruent sides or congruent angles, and then we're going to look at what are we trying to prove, which triangles are congruent to which triangles. So let's look at the first given together. It says B is the midpoint of AE. If it's a midpoint of a segment, then it's going to cut that segment in half and give us sides. We're going to have some congruent segments, which are going to give us sides. Then we're going to look at the parallel lines. And parallel lines, hopefully you know, those always give us what? Congruent angles or congruent sides? That's right, parallel lines give us congruent angles. So which angles are they going to be? Well, let's see. Here are the parallel line from the green parallel line to the transversal and the green parallel line to the transversal. Those are congruent angles. And then you can also do it again from this parallel line to this transversal is the same as from this parallel line to this transversal. So look, what do we have? We have an angle, and a side, which is great because now we have a plan to use angle, angle, side. So let's write it out. So I think I have everything, but let me do my check that I always do. I have a pair of congruent sides, I have a pair of congruent angles, another pair of congruent angles, and even though this says SAA, I know that according to my diagram, I have angle, angle, side, angle, angle, side. So now I can write my final proof statement, angle, angle, side, and I'm done. Now some of you may have had a different method of doing this. Maybe you didn't use alternate interior angles, or at least not 2 alternate interior angles. Did anyone happen to notice that you could have used a set of vertical angles right here? Now if I use that set of vertical angles, maybe I could have said angle, angle, side, or maybe I could have said angle, side, angle. Like I said at the beginning, there are 3 different ways that someone could do this proof. So depending on which way you did it, I'm going to list all 3 now, and you can check yourself. Now, those of you who just copied down what I wrote, perhaps you have a whole page in which to take these notes, right? So why don't you write this proof 3 times, starting with line number 4 is what we're going to redo. So some of you may have thought about this proof in a different way than I did it, and you might be wondering if the way that you chose to do it is correct. So I'm going to go back and work this proof again and see if maybe the next way I do it is the way that you chose to do it. So I'm going to keep step 1 because that's a given. B is the midpoint. I'm going to keep that. And then the midpoint is always going to give us these congruent sides, so we're going to keep that. And in the second given, we're going to keep that. But after line 3, I'm going to erase everything else. Here goes. Okay, I was just joking. I didn't erase everything because obviously we're going to keep the proof statement. That's not going to change. But the way that we go about it might change. Okay, so now I've cleaned off my sketch so that all I have left is what I'm keeping. The congruent sides that were given by the midpoint, and I haven't yet used the parallel lines. If I'm not going to choose to get 2 angles out of the parallel sides, I'm going to need something from somewhere else. Do you see a reflexive? Do you see vertical angles? Those are the 2 things that we need to be looking for. And hopefully you do see some vertical angles here and here. And then you can choose. You can either use angles A and E from the parallel lines, or you could use angle D and C. If I use angle D and C, then I'm going to have angle, angle, side. If I chose to use angle E and A, I'm going to have angle, side, angle. So it depends on whether I choose to use angle E or angle C as my alternate interior angles. So first let's do it using angle E. Angle A is congruent to angle E because they're alternate interior angles. And then I need to use my vertical angles. Okay, and you could have written all vertical angles are congruent, or you could have written the vertical angle congruency theorem like I did, because that's the name of the theorem that says all vertical angles are congruent. So before I do my last step and write whether it's angle side angle or angle side, I need to check what I've written in my statement. So I still have this side here. I have a pair of angles given here. I have another pair of angles given here. And I used, since the side is included, I used angle side angle to do this proof. If instead of angle A and E, you chose to use angle C and D, then the only thing that would have changed is instead of angle side angle, we used angle side. So there were 3 different ways that this proof could be done, and not everybody has to do it the same way. Different people's brains are going to do different things, and that's what's cool about the proofs. So that's it for lesson 4.5.